Hi guys, welcome to another physics video. In this case, we got the last graph, acceleration versus time. So if you can see in the independent axis, well, we got the time, just as the previous videos, okay? The time is always the independent variable. So in the y-axis, we got the acceleration. So in this case, the acceleration, the units that we are going to use are going to be meters per second square. Now, this graph has many other things that the others don't have. And you will see in a moment. So I include a positive acceleration, and also I include a negative acceleration. So everything has a purpose, so bear with me, okay? So for example, we got the same things. We got the horizontal lines for the acceleration. We got the inclination that goes upwards and also the inclinations that goes downwards, okay? So for example, well, in this motion, if you see, we got the acceleration in a positive way, and then it turns negative, okay? So I'm going to do something just as the previous graphs. We're going to have the horizontal line. In a moment, we're going to see the meaning of the horizontal line. What does it mean? Also, we're going to see the meaning of the line that goes upwards and the line that goes downwards. But for example, by seeing this graph, can we identify, for example, this is a car, okay? This is a car that is going to move, okay? So imagine that we have a car over here, and the car is over here, and it's going to start from the rest. So the initial velocity of the car is going to be 0 meters per second. Okay, and then it's going to start the motion with this graph. Okay, now can we know when the car is going to be at rest? I mean, it's not going to move. I mean, the acceleration will be 0. You can say, okay, the car will not move in the horizontal line. Also here in the horizontal line, also here. Or you can say, look at this. The car is not going to move here in the 6th and the 7th second because the acceleration is 0. Well, not really. I mean, it's not necessarily true. Remember that if the acceleration is 0, I'm going to write it here. If the acceleration is 0 meters per second square, well, that means that the car or the object is going to move at constant velocity. Constant velocity. So that velocity could be, I don't know, could be positive velocity, could be, I don't know, could be 2 meters per second. I don't know. But it's going to remain over there. Could be 0 meters per second and it's going to remain with that velocity, or it could be minus, I don't know, 3 meters per second and it's going to remain with that velocity. If the velocity is positive, so that means that the car is moving forward. If the velocity is 0, so that means that it's not moving, not at all. And if the velocity is negative, that means that the car is moving backwards, okay? That's the meaning. Remember that the velocity is a vector, okay? And we got the magnitude, and also we got the sign that is going to give us the direction. But for example, in this moment of time, 6 and 7 seconds, we cannot know if the car is not going to move, because at this point the acceleration is 0, okay? if the acceleration is 0, it's going to move at constant velocity. Okay, so it could be 0 meters per second, or it could be a positive velocity, or it could be a negative velocity. Okay, but that's why I tell you, I mean, this analysis of the graph is really interesting. In order to know if the car is not going to move, we need to go backwards a little bit. When I say backwards, for example, we got position, and then we got velocity, and then we got acceleration. In order to know if the car is not going to move, we need to see backwards. We need to see the velocity. But we're going to see it in a moment. Okay, so before we continue, I'm going to separate the segments by the changes of the inclinations. Okay, I'm going to see something like this. Okay, I'm just going to separate, just as the previous videos that we saw. Okay, I'm just separating the segments, and then I'm gonna tell you an important thing about this. Over here I got another segment over here, and another segment over here, and the last segment. Okay, I'm just separating the graph, and we can say that this is the first segment, this is the second segment, the third, the fourth, the fifth, the sixth, the seventh. We can separate this in two: the 8th, the 9th, the 10th, the 11th, and the 12th. Okay. Okay, so very important. The horizontal line here, okay, the horizontal line means constant acceleration. Constant acceleration. Okay, so remember, the constant acceleration. So remember, the acceleration means that there is a change in velocity. So the velocity might be changing. So for example, if that horizontal line is positive, so for example, in the segment 1, the segment 3, if you see, we got the horizontal line, and that acceleration is positive. For example, here is 2 meters per second square, and here is 4 meters per second square. So that means that the velocity is going to increase. Yes, it's going to increase. But if we see the segment number 7 is an horizontal line and is minus 3 meters per second square, so that means that the velocity is going to decrease. Okay, so in this first, third, and the 10th segment, the velocity is going to increase because we got acceleration, constant acceleration. And remember, the acceleration is a change in velocity, so we're gonna have two choices. The velocity could increase, increasing velocity, velocity, or decreasing velocity. Depends on the sign of the acceleration. As said before, if the acceleration is positive, just like this one, the number 1, 3, and the 10, number 10, the velocity, the acceleration is positive. So in that case, the velocity is going to increase. But in case of the segment number 7, the horizontal line is negative, is minus 3 meters per second square. So in that case, the velocity is going to decrease. Okay? Now, what does it mean, the inclination? Well, that means that there is going to be a change in acceleration. So if you see, from 2 meters per second square, it's going to jump to 4 meters per second square. So there is an increasing in the acceleration. Now, In this course that we are going to see, we are not going to see those changes. But I want to talk about them because I don't like telling my students, hey, that doesn't exist. Okay, there is nothing more. But no, it exists. So for example, if I got here to Wikipedia, we got this concept, jerk or jolt is the rate at which an object acceleration changes with respect time. So is the change of acceleration. Okay, the units, the symbol is the J letter, and the units are gonna be meters per second cubic. You can look for this information in the over the internet. Okay, and other units are standard gravities per second. So for example, these units are very common when they are testing the astronauts. You remember that machine that is going to spin, so they can see if the astronaut can tolerate the gravities, and in order to see when that astronaut is going to pass out or something like that. Okay, so for example, it says here that is going to be the third derivative of the position, the second derivative of the velocity, or the first derivative of the acceleration. So this is more like calculus. If you are going to a faculty and you study physics, well, this is something very interesting, and you might see it. Okay, you might see it depending on the career that you are going to study. Okay, and for example, I said before, it got some application just like the gravities, and also in the in the roller coasters, of course. So, and of course there is more. You got the jerk, you got the snap, you got the crackle, and you got the pop, and so on and so on. Okay, so this one is going to be, I'm gonna write it. This is going to be, okay, we're gonna have jerk, and that jerk is going to be positive. And this one, that jerk is going to be negative. I like this letter, jerk. Of course, it means another thing. So this is gonna be positive, and this is gonna be negative. And as said before, we are not going to see this concept. We are only going to focus in the constant acceleration. So we are going to focus only in the segment number 1, 3, 5, 7, and 10. Okay, and 12, and the number 5. When you see horizontal lines, okay, so I'm gonna check marks. I'm gonna focus on this one, 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 and the number 12. Okay, so those are the only segments that I'm going to see. So if we are not going to see the jerk, well, we are not going to make the calculus about, you remember the slope. The slope, for example, to find the velocity, that was the final position minus initial position over final time minus initial time. Okay, and also we got the acceleration. Well, obviously we're gonna have the jerk, but we are not going to see this one. Okay, we are not going to see. I said again, I'm just going to focus on the horizontal line. So I said before, okay, in order to understand this graph, we need to look backwards. We need to look at velocity. So imagine, for example, that I'm going to simulate the motion of this car, okay? And that car is going to move at, is going to begin with 0 meters per second. So let's do it, okay? I'm gonna make a table that is going to be time. Okay, this table is going to be time. Okay, it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This one is in seconds. Okay, this one is in seconds. Also, I'm gonna have velocity. Okay, I'm gonna have velocity. Remember that it's going to begin in 0 meters per second. This is meters per second. And also I'm going to have acceleration, and the acceleration is going to be meters per second square. Okay, so I'm going to follow this information. So in the second number 0, the velocity is 0 meters per second because I gave that initial state that the velocity is going to be 0. But how much is the acceleration? The acceleration is 2. Okay, the acceleration is 2 meters per second square. So that means that every second the car is going to increase 2 meters per second. So that means that in the first second, okay, in the first second, now the velocity is 2 meters per second, because I said again, the acceleration is the change in velocity, okay, is the change in velocity. Okay, so the acceleration, how much is the acceleration in the second number 1? Well, it is here, so it is also 2 meters per second. So in the second number 2, the acceleration now is 4, because I said the acceleration means that the velocity is going to change 2 meters per second every second. So how much is the acceleration here? Is 2. Okay, now in the third second, okay, now the acceleration is 4 meters per second square. Okay, so that means I'm not going to take into account this one, okay, this one over here. So the jump to 2 at 3 seconds, I'm not going to take it into account. So I'm going to write that this one is going to remain exactly the same. Okay, because this is an increasing in the acceleration. I know that the value of the acceleration is going to be different, but I said I need to make a calculus to see the velocity. Okay, so I'm not going to see it. I'm just going to say that the acceleration is going to remain, the velocity is going to remain there. And then I go to the, okay, I'm here. Let's say, for example, I could say that, for example, this is an horizontal line and the acceleration went this, but that is not possible. Okay, that is not possible. So, okay, I'm going to do something. I'm going to say that, no, okay, the velocity is going to remain. So from this point, if you see, the second number 4, now the acceleration is 4 meters per second square. So the next second, I'm going to add 4 because the acceleration is 4 meters per second square. Okay, so that means it's going to increase 4 meters per second each second. So that one is going to be 8 meters per second. So in the 4th second, the acceleration is the same. So the velocity here is going to be 12. Okay, so in the 5th second, the acceleration is 4, exactly the same. Now, if you see, well, this jump, I'm not going to take it into account. So I'm gonna write again 12. I write it with red color because I know that is not correct, but I said before I don't want to make a wrong data. And I prefer to leave it like that. Okay, so then the 6th second, the acceleration is 0 meters per second square. So that means the velocity is not going to change. So in the 6th second, in the 7th second is 0. So that means that the velocity is going to remain over there. Okay, because there is no increasing and there is no decreasing. Okay, now then the 8th second, in the 8th second, the acceleration is -3. So now it's negative. But there is a jump. Okay, so I'm going to write again 12 in red. I know that is not correct, but I use it just to continue with this um, visualization. So now in the 9th second, for example, the acceleration is -3. So that means that the velocity is going to decrease 3 meters per second each second. So this velocity now is not 12, now it's going to be 9 because it decreased the velocity, okay? So in the second number 10, the acceleration is -3. So again, I'm going to subtract. So this is going to be 6, okay? If you see, the car is not stopping. I mean, it's decreasing the velocity, but it's not stopping at all. Now, in the second number 11, well, now I got the acceleration at 2 meters per second square. So I'm going to write here that is going to be 6. I said again that is not correct, but in order to continue with the analysis of this problem, 13 and 14. So in the second number 12, we got 2 meters per second. 2 meters per second square. So that means that I'm going to add 2. Okay, so this will be 8. And then the second 13, there is a jump. So it's going to remain here, 8. This is going to be 0 meters per second square. And the second number 14 is going to be 0 meters per second square. So that means that final velocity of this object or this car is going to be 8 meters per second. Okay, what I did was an analysis of the acceleration versus time graph. And for example, I could get rid of those inclinations, but I don't know. I don't think that is physically possible. Imagine that I got, for example, imagine that I got a graph that is like this. Oops, sorry, it's like this. And then instead of doing the inclination, it's going to be something like this, boom and boom. Okay, we can do that with our analysis, but imagine this will be a slope, an infinite slope. Okay, I said again, we can work with that, but that will be just in theory, but I guess it's not possible in the physical world, in the real world. But as I said before, and this is just an explanation, and I mark with red those numbers because I know they are not correct, but I hope I made myself clear. And guys, this is the explanation of the graph acceleration versus time. And I really like this topic because it's really good. I mean, you cannot see, you cannot know where the car is going to stop, to be stopped at rest with no motion. You need to make an analysis and you need to see the velocity. That means that you need to jump backward in order to see. So, well, I hope that you really like this video. I mean, I really liked it. I think about if I'm going to make the, if I wanted to make this video or not, because I know that if you got an exam, I mean, this is high school content. If you got an exam, I guess you're not gonna have a graph like this. It will be easier. But I really like to tell my students that, I mean, this is not the end. I mean, there is always more. And if you are curious about it, well, I guess this is a very good video to start. And over the internet, there is a lot of information in the internet, also in YouTube and everything. Okay, well guys, I hope I see you in the next video about physics 2. Bye bye guys.